Hello students, welcome to the second year class of Computer Engineering and Information Technology for the data structure using C subject, and our subject code is 22317. So we will see first today's video's learning outcome. So today's video's learning outcomes are, as we are studying chapter number 5, trees and graphs. In this chapter, we will going to learn about the graphs terminologies. In the previous videos, we have learned about the trees, means the types of the trees, expression tree, and terminologies of the trees, etc. Okay. So first, what is graph? A data structure that consists of a set of nodes, means vertices, and a set of edges that relate the nodes to each other. The set of edges describes the relationship among the vertices. A graph G is defined as follows. G is equal to V, E. In this, V of G is a finite non-empty set of vertices, and the E of G means the set of edges, means the pairs of the vertices. So G is defined as G is equal to V, E. Means it is nothing but it is the non-linear type of a data structure which consists of nodes, means vertices, and the edges. Okay. So example of a graph. V is equal to 0, 1, 2, 3, 4. So and the edges is equal to 0, 1, means this is the 0, 1, 1, 2, 0, 3, then 3, 0. This is 3, 0, and the 2, 2, this is loop, and the 4, 3. Okay. When the x, comma y is an edge, we say that x is adjacent to y and y is adjacent from x. 1 is adjacent to 1. Then 2 is adjacent to 0. 2 is not adjacent to 0. And 3 is adjacent from 1. Okay. Now, directed versus undirected graph. Undirected edge has no orientation, means no arrowhead, and the directed edge has an orientation with the arrowhead. Undirected graph means all edges are undirected, means it consists of edges which has no arrowhead, and the directed graph means all edges are directed. It means it has an orientation with the arrowhead. See here, this is the undirected graph U2V. This is undirected edge because this has no orientation in this edge. So U2V is a directed edge because this arrowhead is at the, it has an orientation this with this arrowhead. So what is weighted graph? A graph in which each and every edge carries some value. It's called as a weighted graph. See here, in this each and every edge has some specific value. Suppose Chicago to Denver, then it has 100. Then Dallas to Chicago, it has a 900. Then Washington to Atlanta, it has a 600, and Atlanta to Washington has a 600. It's like this. Each and every edge has a value. So these are the diagrams for directed graph and undirected graph. So directed graph means directed edge I of I and j is incident to vertex j and incident from vertex I. Vertex I is the adjacent to vertex j and vertex j is adjacent from vertex I. Graph terminology. Adjacent node. Two nodes are adjacent if they are connected by an edge. Then see here, this is the 5 is the adjacent of 7 and 7 is adjacent from 5. Path. A sequence of vertices that connect two nodes in a graph. A simple path is a path in which all vertices except possibly the first and last are different. Complete graph. A graph in which every vertex is directly connected to every other vertex. It is called as a complete graph. A cycle is a simple path which the same start and end vertex. The degree of a vertex I is the number of edges incident on the vertex I. For example, degree of a 2 is 2 because 2 to 1 and 2 to 5, these are the two edges from this vertex. Then degree of a 5 is a 3 because 5 to 2, 5 to 3, 5 to 7 is the edges from this vertex. Are the edges from this vertex. So degree of a 3. Degree of a 3 is 1 because there is only one edge from 3 to 5. It's like this, we can say that the degree of a vertex is the number of edges from that particular vertex. Now, degree of a 4 is what? Degree of a 4 is 2 because 4 to 1 and 4 to 6. It's like this. Undirected graphs are connected if there is a path between any two vertices. Okay. Then directed graphs are strongly connected if there is a path from any vertex to any other. Directed graphs are weakly connected if there is a path between any two vertices ignoring direction. A complete graph has an edge between every pair of vertices. Okay. So loops, edge that connect a vertex to itself. Paths, sequence of vertices P0, P1 up to Pm such that each adjacent pair of vertices are connected by an edge. A simple path is a path in which all vertices except possibly in the first and last are different. Multiple edges means two nodes may be connected greater than one edge. Simple graph means have no loops and no multiple edge. Okay. Multiple edges means what? Two nodes may be connected more than one edge. Graph properties. Number of edges and undirected graph. The number of possible pair in n vertex graph is n into n minus 1. Since edge u comma v is the same as edge v comma u, the number of edges is in an undirected graph is n into n minus 1 divided by 2. Okay. So number of edges in directed graph. The number of possible pairs in n vertex graph is n into n minus 1. Since edge u comma v is not the same, the edge v u, the number of edges in the directed graph is n into n minus 1. Thus, the number of edges in directed graph is less than n into n minus 1 because since it is not the same edge, means it may be b to a, means like this. No? That's why n into n minus 1, the number less than n into n minus 1 in degree. The vertices of I index number of edges index to I, that is the number of incoming edges. In degree means in degree of 2 means in degree of 2 is 1. In degree of 8 is 0 because these are the outgoing edges, not incoming edge. Then out degree of vertex I is the number of edges incidentally from I. that is the number of outgoing edges. Out degree of 2 is 1 and the out degree of 8 is 2. Directed versus undirected graphs. If the order of edge pairs V1, V2 matters, the graph is directed, also called a digraph. V1, V2 is not equal to V2, V1. See here, this is V1 to V2 and V2 to V1. In this order, edges pair V1, V2 does not matter. The graph is called an undirected graph. In this case, V1, V2 equal to V2, V1. Like this, V1 and V2. So, undirected terminology. Two vertices U and V are adjacent in an undirected graph G if U and V is an edge in the G, edge of edge E is equal to UV is the incident of vertex U and vertex V. Okay. Some undirected graphs allows self loops. These will need slightly different notation because U, U is equal to U. Therefore, U, V and U, U to represent the edges of such a graph. The degree of a vertex is an undirected graph is the number of edges incident with it. A self count twice both in counts. It denoted with the DEG V is dig V. Undirected graph terminology. Edge A, B is incident to A and to B. B is the adjacent to C and C is the adjacent to B. This is the self loop. Okay. And this vertex degree is 0. Degree of this vertex is 0. Degree of D is 3 because these three edges are from this vertex. Now directed graph terminology. Vertex U is adjacent to vertex V in undirected graph G if U, V is an edge G. The vertex U is the initial vertex of U, V. The vertex V is adjacent from vertex U. Then vertex V is the terminal or end vertex of a U, V. Now degree. In degree is the number of edges with the vertex as the terminal vertex and out degree is the number of edges with the vertex as the initial vertex. Now this is the directed terminology. See here, in degree of a D is 2 because these are the some incoming edges. These are two incoming edges and out degree of a D is 1 because this is some outgoing edge. One outgoing edge and B adjacent to C and C adjacent from P. Okay. And if in degree is 0, uh, in degree of F is 0 and the out degree of F is 0 because no edge for these vertices. So these are some terminologies of a graph. Now we will see some MCQs. First MCQ is which of the following property does not a simple graph not hold? Does a simple graph not hold? Must be connected, must be unweighted, must have no loops or multiple edge, must have no multiple edge. So simple for the simple graph must have no multiple and must be connected. This property does a simple graph not hold. In a simple graph, the sum of degrees of the vertex is equal to the twice of the number of edges. Answer is true. Now, next is the graph given graph is regular, true or false. So, graph is regular because all the vertices are connected to each other. That's why this graph is regular. Thank you.